Hello. In this video, I'd like to apply Cramer's rule to solve a system with 3 equations and 3 unknowns. If you remember, Cramer's rule is based on using determinants. And a determinant is a value from a matrix. Now for this matrix, we're going to have the determinant of the coefficients, the determinant for the x, the determinant for the y, and the determinant for the z. Let's first start with the determinant for the coefficients. So if I look at the coefficients that are in front of the variables, we have 2, 4, 5, 3, 2, 4, 5, 4, and 7. And I'm going to need to find the value of that determinant. To find the value of this determinant, I can do that using what we call the diagonal method. Using the diagonal method, we have 2, 4, 5, 3, 2, 4, 5, 4, 7. And the diagonal method says that we can copy the first two columns. So the first column was copied at the end, and then the second column was copied. And then we're going to multiply diagonally. This will give me 28. This will give me 60. This will give me 20 times 40 is 80. And then we would add these diagonal products together. So we would have 80, 60, and 28. And that would give us 168. Then what we would do is we would look at the diagonals going in the up direction, and this would give us 50. This here would give us 32. And then here we would have 12 times 7 is 84. We would add those together also. 50, 32, and 84. And we get 166. We would then take the sum of the products in the diagonals going down minus the sum of the products in the diagonals going up. And that would give us 2. So the value for determinant C is 2. I then need my other three determinants. We would have determinant of x, and if you recall, when we do the determinant of x, we're going to take what's to the right of the equal sign, and we're going to substitute that in for the x column. The y column and the z column will stay the same, and we'll get a value for that determinant. We'll do the same for y, in which case we leave the x column the same. The y column will take on the values of the numbers to the right of the equal sign. And then we do the same for z. Remember, we use straight lines to show that it is a determinant. And now I would find the determinants for these three determinants, the values of the determinants. I could do the diagonal method again. There's also a way that we can use the calculator to find determinants. On our calculator, once we turned it on, I'd like to clear our screen. If we go second matrix and then over to edit, this is where we can set the dimensions of the matricing, and then we can put in our values. The cursor moves across, so be careful to put in the correct values. Once we have our matrix in, we will leave that mode, and then we're going to go to second matrix again, but instead of going all the way to edit, we're just going to go over to math, and right here it says to find the determinant. And then we'll have to go back to second matrix, and under the name column, tell it to pick column A, or number 1, which is determinant A, and this determinant is -8. We'll go back and find the determinant for y. So I'm going to go back to my edit. I'm going to change the first column back into its x's. And I will change the y column into the values that were to the right of the equal sign. This will stay the same. I'm going to go get the determinant again. Oh, I'm going to second quick clear just to make sure that I wasn't still in the matrix editing the matrix. Second matrix, math, the determinant, and then second matrix, number 1. I have a 10. And now we're going to go for the determinant for the z. Second matrix, go over to edit. We're going to leave our x column the same, 2, 4, 5. Our y column will change back to the coefficients that were in front of y. And now in our z, we'll put the values that were to the right of the equal sign. Second matrix, over to math, there's the determinant. Second matrix, I'm staying under the names, and the determinant is 2. Once I have my 4 determinants, the x value will be the dx divided by the dc. The y value will be the dy divided by the c. And the z value will be the determinant of z divided by the determinant from the coefficients. So in this case, we'll have -8 over 2, which is -4. We'll have 10 over 2, which is 5. And we'll have 2 over 2, which is 1. So the solution for my 3 by 3 matrix here will be -4, 5, and 1. I'm sure by now, watching all these videos, you know what I'm going to say next. We need to check our solution. So, the question is, if I have these 3 equations and I plug in my values, will I have the correct answer? So I have my first equation, and I'm going to put in my solution, -4, 5, and 1. And I'm going to check to see if that gives me 12. And I'll have -8 plus 15 plus 5, and indeed that gives me 12. I have my second equation. I'm going to have to go ahead and put in my -4, my 5, and my 1. So I have -16 plus 10 plus 4. Does that equal -2? And yes, it does. And then I have my third equation. And my third equation was 5x plus 4y plus 7z equals 7. I'm going to have to substitute my point in. And that point was -4, 5, and 1. -20 plus 20 plus 7 equals 7. Yes, it does. So here you have a nice video demonstrating to you how to use Cramer's rule to solve a 3 by 3 system. We had some notes on using the diagonal method to find the determinant, and we used the calculator to find the determinant. Hope you find this helpful. Please add this to your algebra journals. If you need more help, please come to A&P, and we will also practice in class. Thank you.